This is second section of chapter 2. It deals with applied problems, which are story problems. On page number 69, there's a red box there that kind of goes through and tells you some things that you should do. Defining your variables, drawing a picture if it's helpful, listing out the facts of it, and then writing your equation and solving it. When you list out the facts, a lot of the times you're going to be using some formulas, not all the time, but sometimes you will be. Some of the formulas that you're going to end up using are these. They're all basically the same thing. Distance equals rate times time. Cost equals the number times the price. Interest equals the principal times the rate times the time, or sometimes just principal times the rate. And then a solution or a mixture equals the percent of some solution times the total solution. And I'll pause here and give you a moment to write all that down. Then, using these formulas, it's sometimes it's very helpful to put the stuff into the form of a table so you can get it organized and make it easier for yourself to write the equations. Sometimes maybe your table only consists of two different things, like car 1 and car 2 going somewhere, so you'd have rate, time, and distance over the top. Other times when you're using this one here, you have an original solution, you're going to add something to it, and then you get a new solution. So then the easiest thing to do is put it in the table, like I said, and you have your percent, total solution, and the solution amount. Oh, it depends on what the question is. Sometimes you may use this top chart for any of these. All right, so we're going to look at a couple of examples. Now, you don't have to, is when we go through the examples, you'll see. The two examples we're going to do are they're actually out of your book because there's questions 12 and 13. Things before that, like 1 through 8 or 9, I don't think you need to use the chart or anything with them. Okay, so for question 12, it says hourly pay. A consulting engineer's time is billed at $60 per hour and her assistant is billed at $20. A customer received a bill for $580 for a certain job. If the assistant worked 5 hours less than the engineer, how much time did each bill on the job? And so here's an hours worked times the wage per hour equals their total wage. And so we put this into a chart, and now we just have to figure out each person and how much they get. And we have the engineer, and this is the assistant. And what does it say about the hours worked for either one of those two? Yeah, but not that's the wage. So, okay, let's go to the wage first then. So the engineer had what? 60. And the assistant 20. Okay, then it says, what about how much time they worked? Okay, the assistant worked 5 hours less than the engineer. So then that means one of these two has to be X. And it doesn't matter which one you put as X. So if you put the engineer as X, the assistant worked 5 hours less, so then that would be X minus 5. Now, had you gone the other way and said this one was X, then this would be X plus 5. Either way, it doesn't matter. So now you have to multiply these two things together to get your total wages for the engineer, which would be 60X. And for the assistant, which would be 20x minus 100. And it says that the total bill was $580. So then your equation would become this column, 60x plus 20x minus 100 equals 580. Now then you're going to have to solve this by adding 100, and you get 80x equals 680. And then finally, dividing by 80, x will equal 8.5. And so now x in our table represented the engineer's number of hours worked. And the question wants to know how long both of them did. So then you would say the engineer worked 8.5 hours, and the assistant worked how many hours? Okay, 3.5. Because it's 8.5 minus 5. And so then that's your answer. Okay, then looking at question 13, it says in a certain medical test designed to measure carbohydrate tolerance, an adult drinks 7 ounces of a 30% glucose solution. When the test is administered to a child, the glucose concentration must be decreased to 20%. How much 30% solution and how much water should be used to prepare 7 ounces of a 20-ounce glucose solution? And so this one now we're going to need to use this bottom formula. The solution equals the percent times total solution. So the thing we have is the percent times the total solution equals the amount of glucose, because that's what it's dealing. It's a glucose solution, so it's always whatever is in that thing. The new solution, it says at the end, has to be 7 ounces of a 20% solution. So our percent here is 0.2, and there's 7 ounces of it total. And so then how much glucose is in there? Well, you just multiply those two together to get 1.4. The original solution, which is an adult solution, is a 30% solution. And we also have water. And what percent of water is glucose? Okay, so that's going to be 0. Now we have to figure out how much of each one of these two we have to put together in order to get 7 ounces. That'll be 20%. So one of these two things has to be x. It doesn't matter which one. If you want water to be x, then this would be seven minus x, because they have to total this down here. And then if you multiply these things together, 0 times x is 0. 0.3 times 7 minus x is 2.1 minus 0.3x. And so now your equation is going to be 2.1 minus 0.3x equals 1.4. Then solving for x, you would first subtract 2.1. You get a negative 0.3x equals a negative 0.7. Then you would divide by negative 0.3. And you will get x equals 2 1/3. I think it's 2.3 repeating. So if x is 2 1/3, that was the amount of water we needed to add. So we would have to say add 2 1/3 ounces of water with 4 1/3, not 1/3, 2/3. 4 2/3 ounces of the adult solution. And that will give you the proper 20% solution for a child. And that's what this whole section deals with. So take your time going through them, read the questions, try to make yourself some table and fill it in, and then use probably the last column as the one where you need to make an equation. So you can use the rest of the time today to work on this today.